All right, seventh grade. In this video, we're going to be taking a look in your Eureka Workbook, Module 1, Lesson 3, and we're going to be continuing our discussion on proportionality. And in this lesson, we're going to be examining some more proportional relationships, so we'll be continuing that discussion, and we'll be looking at some non-proportional relationships in tables. Now, you all are familiar with tables at this point from last year, from sixth grade. So, just as I demonstrated in at the top of the last lesson, sometimes it's easier to look at these proportionalities in tables. And I gave the example of gas to dollars, right? So, if a gallon of gas costs $2, then that's a proportion, yeah? So naturally, it follows that 2 gallons of gas would cost $4, 3 gallons would cost $6, and so on. And so sometimes, a lot of times, you'll see proportions broke out into a table like this. I think it looks nicer in here. And we're going to take a look at some examples within tables. All right, so in example 1, we'll read, you have been hired by your neighbors to babysit their children on Friday night. You are paid $8 an hour. Hey, that's pretty good. That's above minimum wage. $8 an hour. Okay, great. So we're going to complete the table relating to your pay to the number of hours you worked. Fantastic. So now, based on the information we're given, how many dollars will we make in 1 hour? Yeah, if we're paid $8 per hour, then we're going to be making $8 in that first hour. Very good. So then how much would we make on the second hour that we worked? Well, we would just get another $8, right? So we would just add $8 and we get to 16. All right, so from here, you're going to spend some time, and if you're working in your workbook, you already know that there's a few more blank spots for you to fill out. So on the left side, they give you the number of hours, and you are going to calculate pay based on the number of hours. I'm going to give you 2 minutes to work through this. All right, the time has to start to go. Very good. All right. So most of you may have noticed the trend that every time here we're multiplying the number of hours by 8 because she's paid $8 per hour. He, she, they are paid $8. We are paid $8 per hour, right? It's us, right? So for every hour, you get $8. So we multiply the number of hours times 8 each time, following this pattern down. That means at third hour, we made $24. After the fourth hour, we made $32. That's right. 4.5. I'm going to skip this one for now. At 5 hours, though, we'll have made $40. And 6 hours, 48. 6 times 8 is 48. And I'm going to skip this one as well for right now. So I wanted to discuss 4.5 hours. So first of all, how did you figure out how much that we would get paid at 4.5 hours? How did you come about that? Okay, very interesting, very good. So we know that 4 hours we would have got paid $8 an hour, so we made $32 right here at 4 hours, right? So we need to add an extra half hour of work. 1/2 hour of work. Well, even if I didn't know how to multiply 1/2 times 8, I know that 1/2 of 8, right, is 4. And that makes sense that if we made $8 in a whole hour, then in a half hour, we would make $4, assuming that we're getting paid for the half hours, right? So half of $8 is $4. Wow, this is my screen's not working as well as I hoped. So hypothetically, if everything's proportional and we're actually getting paid for that half hour, then we would get paid $4 in that amount of time, right? So we got paid $4. We got paid $32 for the 4 hours, plus $4 for the half hour additional we worked. So that is 36 doll hairs. All right, and then come down and what about this right here, 6.5? What is 0.5? How much is of a whole is 0.5? Very good. 1/2 is equal to 0.5, right? Very good. And we can prove that by dividing 1 by 2. 1/2, remember fractions are just division problems, so 1 divided by 2 is 0.5. For those of you who already knew that, I apologize for wasting your time, but that's a pretty common decimal that you're going to see. 0.5 is half. So we have here 6 whole hours, which we got paid $48 for, plus the 0.5, which we'll get paid 4 for. So we just add that up. 48 plus the $4 for the half hour means we made a total of $52. Okay, so based on the information in the table, is the pay proportional to the hours worked? What do you think? Okay, now explain your thinking. How do you know? Remember, use complete sentences, complete thoughts, 90 seconds. Give me an explanation of how you know. So a full points answer response, I should say, to this problem right here. It is an example right here. So I said our pay is proportional. So again, I restated the question. Is pay proportional? Our pay is proportional. I restated the question. Our pay is proportional because, and if you're in ELA, if you're in English, your teacher may tell you that because is a redundant conjunction, but that's fine because our pay is directly related to the number of hours we worked. So I explained my thought, my thinking, and complete thoughts. Even if you didn't answer this question correctly, in an operational sense, you said it was not proportional. If you explained your thinking, you're still going to get points. So don't forget about that. Okay, so before we leave this problem, I want to pose this question to you right here, okay? So let's say we get asked to babysit overnight. Okay, so we babysit overnight and we still get paid the same rate, but we worked 20 hours. So if we work 20 hours, how much money are we going to make if we're making the same rate? Okay. Very good. So we would just multiply 20 times 8 and we would get 160. That's pretty good. Wow. Okay, very good. Now, all right, so one more time, slightly different scenario, okay? If you need to, you can make a box out over here. I just kind of erased my boxes down here, but and you can just kind of fill this in wherever. But let's say our friend is also babysitting, and they babysit at the same rate as we do, right? So there's no competition, right? We're collaborating to set the market price, right? So all right, so they get paid $8 an hour as well, and they also do an overnight babysitting job, and you go back, y'all come out, y'all meet, y'all talking on the phone, and your friend is like, oh, I made $100 the babysitting. How many hours did your friend get paid for if they got paid $100? How could you figure that out? Well, we talked about examples like this in the last lesson, right? So from the number of hours to our pay, we're multiplying by 8. So going from pay to number of hours is just the reverse. It's the opposite. We divide by 8. We do that, and this is, so 40 divided by 8 gets us 5 in this example. Wow. So we would divide $40 by 8 to get our number of hours worked, which is 5. So going from $100 made to the number of hours worked, we would simply divide by our unit rate of 8, which in this case would get us, I could probably figure that in my head, 100 divided by 8. That means we work 12.5 hours, and again, 0.5 means 1/2, so an additional half hour, which half an hour is 30 minutes, 12 hours and 30 minutes, which is pretty good for half a day's work, I suppose, depending on how good the kid is. But what we did here, so we divided 100 by 8, which is actually the same as multiplying 100 times 1/8, or the reciprocal of 8 of our unit rate, right? If we look right here, 100 can become 100 over 1, right? Any number over 1 is just that number, times 1 over 8. So we multiply tops times tops, bottoms times bottoms, numerators times numerators, denominators times denominators, and we get 100 over 8, right? And we simplified this by dividing 100 by 8, which got us 12, and we could say 12 and 4/8, which equals 12 and 1/2, which equals 12.5. All right, so following that example exercise, exercises 1 through 3, wow. Exercises 1 through 3, determine if y, which is just some value in the model, in the table, is proportional to x. And you're going to justify your answer. So each one of these is going to have a table, an x, and a y, and you're just going to determine whether that relationship is proportional, or no. C or no. You just y'all have to take about 7 minutes. Work problems 1 through 3 on your own independently. Determine if the tables are proportional, and just come back. If you want to, you can go through each one and just write proportional for each or no after you've determined whether it is or not. That way you don't have to write. We'll get some practice in writing out full answers using these. But just first, I would just advise just figuring out whether they're proportional or not. Great. Okay. Fantastic. So let's look at this first one. First of all, wow, I just appreciate y'all working so hard. I really do. Thank you. It means a lot. Your effort means a great deal. Okay. Let's look at example 1. So in this table, The table below represents relationships in the amount of snowfall in inches in 5 counties to the amount of time in hours in recent snowstorms. So you can tell that Eureka was written in the northern part of our country because we don't really have this problem, do we? Okay, but let's just go with it, right? This in this first ratio subset, we have 2 hours and 10 inches of snowfall. So in those first 2 hours, this was just raw recorded data. In those first 2 hours, they recorded 10 inches of snowfall. So how many inches of snowfall per hour did that happen? Did have happened? Well, we could just divide, right? We can divide 10 inches, total inches in 2 hours by 2, and that would mean our unit rate for this set would be 5 inches per hour, right? And I think it would help to write this out over here, a little bit of shorthand. So 5 inches per hour. Okay, so let's move on to the next subset. If in 6 hours, 12 inches of snow falls, how many inches per hour was that this time? Well, we can do it just like we did last one. Divide the number of the inches of snowfall by the number of hours, and that would get us 12 over 6, or 12 divided by 6 happens to be 2 inches per hour. So, just based on what we have so far, is this relationship, is it proportional? Proportional or no? Great, very good. Yes, no. This is not proportional. We already see our rate of change changing, right? It is not constant, right? So we don't even need to keep going down because if one of these does not match in the set, if one of these rates doesn't match in the set, then we already know that it's not proportional, right? Now, for these few answers, just writing proportional would be fine, okay? And if you show some sort of work like that, that'll work as well, right? We could, so this would be a full point answer for you, right? The relationship between time and snowfall is not proportional. I already stated the question. Proper English, complete thoughts, great. We're going to move forward to the second set of numbers, the second chart right here. And in this chart, in the table below, shows the relationship between cost of renting a movie in dollars, so cost in dollars, and the number of days the movie was rented. So X is number of days, Y is the number of dollars spent, right? So again, we can determine our cost. Now, whenever you're searching the unit rate, we talked about this in lesson 1, or lesson 2, I should say, how it doesn't matter whether you're determined. So let's say, how do I say this? Let's just say in this example, we divide the total number of days by the cost in dollars. So we divide 6 divided by 2. Well, that would get us a unit rate of 3. But what does this 3 mean? Well, we divided the number of days by the number of dollars. So 3 represents the number of days we can rent a movie for $1. Days per dollar. I didn't need to write out dollar. Let's say we wanted to, hello. But then let's say we wanted to determine our unit rate by dividing cost in dollars by number of days. Well, we would divide 2 by 6. That would be 2 over 6, or 1/3. And so what would that 1/3 mean? Well, what that 1/3 would actually mean is that we would get, it would cost us 1/3 of a dollar, so 1/3 of a dollar per day. So over here, we found the unit of the dollars per day, and over here, we found the days per dollar. And as you may have noticed, that either way you do this, whether you did over here dollars per day uh, or did days per dollar, what you'll find is that they are actually reciprocals of one another. So your unit rate over here is 3, which is the reciprocal of 1/3. They're flippity floppity, right? Flippity floppity. Reciprocal, multiplicative inverse. Fantastic. So whichever way you choose to look at this here, whether you would rather think about it in terms of dollars per day or days per dollar, you would just want to make sure that you compare it the same way for each one of these columns, right? So let's go to the next column and let's compare. So let's say we want to get dollars per day or days per dollar for our second column, second set of numbers right here. So 9 days cost $3. So again, we would divide number of days by dollars. 9 divided by 3 is 3 days per dollar. So far it seems that we have a proportional relationship, right? Now, just for the sake of argument, let's go the other way now. Let's calculate dollars per day. So we would divide 3 by 9, and that would get us, again, 1/3 dollar per diem per day. Right? So far, it looks like we're proportional. All of these unit rates are the same so far. So let's keep going down. 24 divided by 8 would be 3, right? And if it's 3 over here, it's going to be 1/3 over here. We're going to ignore this other side for now. Anyway, if it's $3 a day over here, then it's 1/3 of a dollar per day. 3 days per dollar, I should say. Right, and then right here, how many days do we get per dollar? If we spend $1, we get 3 days. So 3 days per dollar. Okay, so all of these sets of numbers are proportional to one another. They all have the same unit rates, whether it's dollars per day or days per dollar, they all have the same unit rates. So this is a proportional relationship. Make sure you write your answer out in complete thoughts, right? So the relationship between days and the cost is proportional, right? Fantastic. I don't need to sloppily write this out in this pen for y'all to see it, right? Please let me know if you have any questions about this one so far. And then let's go to the last example, and I'll knock this one out just a little bit more quickly, since it's very similar to the other ones. So amount of candy and the cost per dollar. I don't even care about the word problem. The table shows, great. The amount of candy in pounds and the cost per dollar. So, please excuse me. If I pay $10 for 5 pounds of candy, that means each pound of candy is going to cost me $2 per pound, right? So does this follow, right? Does it cost me $2 per pound each time? Well, right here, I spend $8, I get 4 pounds candy. 4 pounds candy times 2 does equal 8. So far, that's looking good. So this should match going down. 6 times 2 is 12. Good. If it's $2 a pound, then 8 pounds should cost me $20. Should cost me $16, and 10 pounds should cost me $20, which they in fact do. All of these things are true. Check. This is proportional. Write your answers in a full sentence. Great. All right, we're going to come down to this final example problem together. All right, so in problem 4 in our classwork, Randy is planning to drive to New Jersey from New Jersey to Florida. We don't care about Randy, that's fine. Every time Randy stops for gas, great, he does. He records the distance he traveled in miles. Cool, okay. So that's what he's doing down here, all right? So this first stop, he traveled 54 miles, and he's saying that he consumed 9 gallons of gas, okay? See, he's recording both of those things. He's recording total number of amount of gas and, yeah, the miles that he traveled by each stop. Fantastic. Okay, so we're going to assume here, because this problem is telling us to, we're going to assume that the number of miles driven is proportional to the number of gasolines. Well, that's interesting. Number of gasolines consumed in order to complete the table. Am I reading? Assume that the number of miles driven is proportional to the number of gallons. I can't read. Number of gallons consumed in order to complete the table. Okay, so it is proportional. It's telling you that. So you are going to assume that all of these are proportional. And I want you to finish filling out this table. Take approximately 90 seconds from right now and finish filling out that table. Okay, cool. So what you should have come up with is that assuming that all of this is proportional, which we can check right here, but just taking this first example. So his first stop was 2 miles or 2 gallons of gas were consumed, and he traveled 54 miles. So his first stop was at 54 miles. He had consumed 2 gallons of gas. So based on that, how much gas is he using per mile? What's his unit rate? Right, you would divide the number of miles driven by the amount of gas consumed. 54 divided by 2 is 27. You did that math. You can do long division? Yes. Unit is 27 miles per gallon. We've seen this example before. We've talked about it in class and in previous lessons. So 27 miles per gallon in this car. So based on that, if he uses 4 gallons of gas, I should say, because gallons consumed was 4, how far did he go? Well, you can take out your handy calculator, multiply the miles per gallon times the gallons used, and that means traveled 108 miles. Very good. You multiplied that. You know how to do multiplication. Very good. 108. Very good. All right, but what about right here? So in this stop, he stopped at 189 miles. So already, I don't think that's going to divide perfectly, is it? But we'll find out. How could we have calculated the gallons? I think I gave it away. The gallons consumed. Well, the answer is if we multiplied going from gallons to miles, we would divide going from miles to gallons. So if we traveled 189 miles, we'll divide that by our miles per gallon, 27 miles per gallon, which means we used 7 gallons of gas. Very good. Great. And we can continue this process going down. So if 10 gallons were consumed, that means 270 miles were driven. And this would be 324. Yes. 324, and I'm going to check that. Wait, 12 times 27? Yeah. 324. I'm a math genius. Great. Okay, so why was it important for us to know that the miles driven were proportional to the number of gallons? Why is that important? Because if it wasn't proportional, then all of this stuff right here could have been completely random, right? If we didn't know it was proportional, we couldn't safely assume that we multiply 10 times 27 or 12 times 27 to get our number of miles per gallon. What about the other one, the other piece of information we were given? So here we were given 8 gallons consumed in 216. So does that make sense? 27 times 8. Yeah. So if we didn't know it was proportional, then we couldn't use this process, right? And again, we multiplied going down and we divided going up. Okay, great. Thank y'all for your attention. Seriously, guys, thank y'all for working so hard. So in closing, how do we use tables to determine whether the relationship between two quantities is proportional? Well, we looked at a couple of different examples of how we could, right? And here in the lesson summary, before you get to the problem set, you'll see a type of quantity is proportional to the second if there is a constant number, right? And that was that unit rate that we calculated, right? If there is a constant number such that the product of each measure, oh wow, the first type and the constant is equal to the corresponding measure of the second type, which isn't that complicated, right? We go back to our fourth example here. Our constant was 8, right? Or no, 27, right? 27 miles per gallon. So we multiplied the number of gallons by 27, our unit rate, to get our miles driven each time, right? And so that 27 was constant between each one of our examples. And here you have some steps to determine the quantities are proportional for each row. Calculate B over A. Again, we talked about this, right? And when they say B over A, they're just saying one of the numbers over the other number, right? So like in these examples, we did well in the first. This is the first example. This is the first. So in this one we divided both, right? We divided the time by the hours and the hours by the time, or the inches by the time. Yeah. So okay, great, awesome. All right, let's continue with the lesson summary and get done with this lesson and move forward to the problem sets. Okay, and then very good. Where A is the measure of the first quantity, B again, just A and B are two different quantities, and you calculate your constant by putting one over the other, all right? If B over A is the same for each pair, right? It has to be for each pair of quantities. The table is proportional. All right, great. Or yes, great. Problem set. Thank you. I'll see y'all in the next video.